Okay, so we're going to look at integers. So previously, we've been dealing with the set of whole numbers. And whole numbers start with 0, and they move up by steps of 1. And you can keep going all the way to infinity. What we want to do now is we want to get the idea of what happens if, in whole numbers, if I were to do a subtraction, 1 minus 3, I get something that's less than 0. And so there is no whole number less than 0. And so we want to have something that answers this for us. And this came up, like Babylonian culture has some early history of people owing money for taxes. And this was kind of where the idea of debt came to. They would grow crops, and they would need to make sure that they would give so much of the crops to the government, and if there was a bad year, they would end up owing for the grain storage for the next year. So what we do is we take 0 and we fix it as an origin, and we can go positively, which is generally done to the right, with the whole numbers. And then we can go negatively, which is generally to the left, with what we'll call negative numbers. And so the negative sign shows direction. In fact, we'll put the stuff to the right, we'll say they're positive numbers, and the stuff to the left are negative numbers. And 0 becomes an origin, a starting point. And technically we could write this as +1, +2, +3, but we don't write the plus sign, mainly because it is redundant. It's assumed to be there with the numbers. And so we call this thing the number line. And it's a way of comparing values with these new things called integers. And so if I write the set of integers, which tends to get a bold Z, which I think is from the German word for integers, we start from an infinitely small number, very largely negative. We work our way towards the origin by steps of 1. And then we grow away from the origin towards positive infinity. And so our list of negative and positive numbers are the things that we call integers. And what helps really nicely is integers can kind of talk about the depth of things or the position of things. So an example your book talks about is that there's a bat colony in a mine at a depth of 3,805 feet. And so if we think of the surface of the Earth as a 0, and if I go up in an airplane, I'm going positive feet. And so if I come down this mine, and I get to this bat colony down here at 3,805 feet, we'll say it's negative because it's below the surface. And so we'll talk about things above the surface as positive and things below the surface as negative. Let me see if I can draw little bats hanging in the cave. Right, and I guess there's other mine shafts going off of here. Right, but down in the depth of this mine shaft, right, there's a bat colony. And so the integers become a way of also talking about position. Well, the number line does a really nice thing for us. By having these positional ideas of numbers, we can compare numbers on what's bigger or what's smaller. 1, 2, 3. Since position now takes ride over quantity. And so I can say less than or greater than. And so any number that goes to the right is bigger than some number that goes to the left. And so we can compare two numbers. So let me get a better number line here. I'll have the origin here. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I can talk about the number -3. So I'll move 3 to the left. So this is -3. And I can talk about the number -5. And we can say -5 is less than -3. And so this points to the smaller number. And the smaller number is to the left. I could say -3 is greater than -5. Again, this points to the smaller number. And by having this positional idea, we can talk about left and right as ways of being bigger or smaller. Now, position gives us another idea, which would be distance, or how far you are from the origin. So I'll look at 3 and -3. If I only count the spaces I'm hopping, I hop 3 spaces to the right to get to 3, and I hop 3 spaces to the left to get to -3. And so we can call this an absolute value. And we put these 2 bars between the number, and we're talking about the number of spaces. The answer to an absolute value will always be positive. So if I want to know how far -3 is from 0, it's 3 spaces. And so the absolute value which is used by this symbol surrounding things, does that. It counts the distance we are from the origin. So, for example, the absolute value of -8 would be 8. Because I'm 8. 1, 2, 3, 4, 5, 6, 7, 8. Right, -8's over here, but there's 8 hops to get to 0. And so the absolute value of 9 is 9, because there's 9 hops to get to 9. And the absolute value of -15 is 15. And so the absolute value does the work of dropping off the sign. Now, when I have two numbers like 3 and -3 that have the same absolute value, so the absolute value of -3 is equal to the absolute value of 3. And we call these numbers opposites, because they're on opposite sides of 0. And so what happens with an opposite, change colors here and brighten things up a bit. And get some space. oops, running down towards the bottom of the blackboard here. If I write 4, the opposite of 4, well, to get an opposite, I put a negative sign in front of it. And so I get -4. If I have -4 and I take the opposite of it, I get to 4. What happens is whenever we start stacking up two negative signs side by side like this, they become a positive because the opposite of a negative is a positive. When I put a negative sign in front of a positive number, I get -4. We get a negative number. And so one of the things we'll look for is when we start stacking two negatives together, we'll see that the rule of opposites will give us a positive number. All right, and so this is kind of the overview of Chapter 2, Section 1.